let's take the task of graphing a function and its inverse. Let's try to make it easy. We can look at a function and get an idea of what will be the vertex. Our vertex is going to be the opposite of what we see with x and the other number as it appears. So that means our very important point will happen not at -6, but +6 and +2. So we've got a point. Now we would like to see the full figure of this function. To do so, let's make some choices for x. We'll make good choices. Choices around 6, bigger than 6, and smaller than 6. That's how I choose them, knowing where to start, bigger and smaller. When we choose for x to be 6, we find the y value is 2. If x is 7, y is 3. When x is 8, y is 10. If x is 5, y is 1. When x is 4, y is -6. Let's plot these points. 6, 2, 7, 3. We've got 8 with 10. Right around here. 5 with 1. And 4 with -6. Okay, connect them. Let's see that snake shape. Characteristic of a cubic function. This snake is located to the left, to the right and above the origin. Okay. Now that we have sketched the graph of the original function, let's sketch the graph of the inverse function. Don't make it hard. Don't solve an equation for the inverse function. Let's use that characteristic, the way that an inverse function is related to a function. The x's and y values are switched. Not the 0.62, 2.6. Not 7.3, 3.7. X and y, they switch roles. 10.8, 1.5, -6, 4. Let's plot them. We have a point where 2 meets 6. Here it is. 3 meets 7. 10's going to meet 8. Aha. 1 meets 5. And -6 meeting 4. Connect them. Let's see that sideways snake we've come to expect from a cube root function. Oh, aren't you just beside yourself looking at the symmetry? This function and the inverse function, they are symmetric. Around the line y equals x. That's because their x and y values are switched. Oh, it is joy.